Hey everyone, and a huge welcome to This Explainer. I am seriously thrilled to have you here today. If you're focused on truly mastering software quality, well, you are exactly in the right place. Today, we're totally demystifying database testing. Our main goal here is to bridge that massive gap between what you see happening on the front-end user interface and the back-end database validation that absolutely must happen behind the scenes. We're going to build this up step by step, starting with the core concepts and working our way all the way up to automated testing.
Okay, let's dive into this. And let's start with a very real scenario. Imagine you're testing a web application. You fill out a registration form, you hit submit, and boom, a shiny green pop-up says, "User created successfully." But did it actually work? This is what I like to call the UI illusion. Just because the front-end interface tells you the data was saved doesn't actually mean it was stored perfectly or stored at all in the back-end database. To really guarantee quality, we can't just blindly trust the front end. We have to verify the back end.
So here's our roadmap for today. First, what database testing actually is. Then, we'll hit core database concepts, move right into manual testing with SQL, shift over to automation powered by JDBC, and finally, bring it all together with a real-world example. Section 1. What is database testing? Validating the UI illusion. Database testing is, by definition, validating that the data displayed or submitted on the user interface perfectly matches the data stored in the application's backend database. Essentially, it's a strict synchronization check. Think about it. If you add a user on the UI, that exact same user record must appear in the backend. If you update a user's experience from, say, 10 years to 12 years on the screen, or delete a record entirely, those exact changes have to instantly and perfectly sync with the backend database.
And this brilliantly illustrates the core dynamic we're testing: UI data versus database data. What the user actually typed into the web form literally must be exactly what is safely tucked away in the backend storage. If there's any mismatch at all, like say the UI drops a digit from a phone number before saving it, that is a massive bug.
Section 2. Core database concepts, the foundations. Before we write any code, we need to know what we're talking to. Most modern projects use an RDBMS, or a relational database management system. Think of widely used software like MySQL or Oracle. This is software that organizes and stores related data in a highly structured table format using rows and columns. And why do we do it this way? Because organizing it like a grid makes it incredibly easy to logically create, retrieve, and update that data later on. Let's break down a concrete example of this table structure. We have a simple employee table here. Notice how the related data is perfectly, cleanly organized. We've got columns for employee ID, name, location, and experience. Each row represents one complete record. For instance, row 2 is Gopal. He's from Bangalore, and he has 8 years of experience. This exact relational grid is precisely what we are verifying when we do database testing. Section 3. Manual testing with SQL, speaking to the database. So how do we actually talk to these tables? We use a language called SQL, or Structured Query Language. This is the standard programming language specifically designed for managing and interacting with relational databases. Basically, think of SQL as our direct line of communication to the backend. There are 4 essential manual SQL commands that every tester absolutely must have in their toolkit. First up is select, which we use to retrieve or fetch data from tables. Second is insert into, which lets us create entirely new records. Third is update, which we use to modify existing data in a row. And finally, delete, which, as you'd guess, removes existing records. By mastering just these 4 commands, you can manually manipulate and verify pretty much any data state. Now, what's really interesting about this is how we can filter things. A manual tester rarely wants to pull thousands of records all at once, right? To be highly specific, you use conditions like the where clause. This query is literally saying, select all columns from the customer's table where the city is strictly equal to London, and then order those results by country in ascending order. This is exactly how you surgically filter down to exactly the data you need to verify. Section 4. Automation powered by JDBC. Bridging Java and the database. All right, before we connect via code, we need to know exactly where the database actually lives on our computer or server. I love using the hotel room analogy for this. Think of your local machine, or local host, as a massive hotel. But a hotel has thousands of rooms, right? So where is the MySQL database specifically? By default, MySQL lives in port 3306. That port number is your exact room key. We literally need both the hotel address and the specific room number to make the connection. To actually make that connection from our Java automation code, we use JDBC, which stands for Java Database Connectivity. This is a super powerful API in Java. You can think of JDBC as the vital bridge that allows our automation scripts to securely knock on port 3306, connect to the database, speak SQL to it, and bring those results right back into our Java program. Programmatically, utilizing JDBC follows a very logical 5-step flow. Let's walk through it. First, you register the specific database driver, like the MySQL connector. Second, you establish the connection using your credentials and that exact hotel room address we just talked about. Third, you execute your SQL query just like the manual select statements we reviewed. Fourth, you assert the results, which is where the actual testing magic happens. And finally, step 5, always gracefully close the connection to prevent memory leaks.
Let's look at step 2 in action. This string right here is the Java connection URL. Notice how it pieces the whole puzzle together. It specifies JDBC connecting to a MySQL database. It points to localhost, which is our hotel, and specifically to port 3306, our room. Finally, it targets a specific database named QFox. This one string is the exact map your code uses to find the data.
When it comes to step 3, executing the query, you really want to avoid just pasting raw strings if your data is dynamic. Instead, we use a fantastic feature called prepared statements. These allow us to write a query with question mark placeholders. Then, we use methods like setString or setInt to security pass dynamic variables from our automation script directly into the query. It's so much cleaner, it prevents weird syntax errors, and it perfectly bridges our Java variables with our backend SQL commands.
Section 5. The real-world example. Front-end meets back-end. Let's move to and see how this builds into a complete end-to-end automated test. Step 1. Your Selenium Java code opens the browser, types a new user's details into the registration UI, and clicks Submit. Step 2. In that exact same JavaScript, JDBC quietly connects to the backend MySQL database and executes a select query for that new user. Step 3. We capture the data the database gives back to us, and we compare it directly against the data Selenium just typed in.
And here it is, the ultimate aha moment in your test script. Assert.equals. On the left side, we have UI first name, the exact string Selenium typed into the web browser. On the right side, DB first name, the exact string JDBC just pulled out of the backend table. This single line of code completely proves that the front-end illusion actually matches the backend reality.
So, the crucial point is this. Your test will either pass or fail purely based on data integrity. If Selenium typed Aaron and the database saved Aaron, the data syncs perfectly and the test passes. But if the database saved a blank space or truncated the name, the assertion fails. The test stops, and congratulations, you have mathematically proven the existence of a back-end bug that UI-only testing would have completely missed.
By combining Selenium for the front end and JDBC for the back end, you unlock a completely airtight level of software quality. Which leaves me with one final question for you. If you are only testing the user interface today, how many hidden bugs are lurking in your back end right now? It's time to start querying those databases. Thank you so much for joining me for this explainer. I hope this helps you build bulletproof automated tests. Happy testing.